Hi everyone. So in this video, we're finally going to introduce what trigonometric functions are. And the majority of this video is going to be focused on how to evaluate trigonometric functions, being really clear on the definition of how they work, and then also doing a bunch of examples. But before we get into that, I just want to give you a little bit of context. So this part, I'm going to be writing a bunch of stuff down. Hopefully I won't be too slow. Sometimes I'm not so good at talking while I write, but I'm going to do my best here. I just want to make sure I'm not plunging you right into trigonometry without you understanding kind of how we're going to be using it in this class and how it maybe fits in with other things that you've learned. So first thing I want to mention is that trigonometric functions, they're functions, just like other types of functions. So when you were in Math 141, or whatever your pre-calculus 1 class was, you learned about a lot of different types of functions, right? You learned about a variety of types of functions. So some of the functions that you learned about, or at least that you should have learned about, were linear functions, polynomial functions, rational functions. If you don't remember exactly what all of these are, don't worry too much, but I just want to kind of list them off. Rational functions, exponential functions, and finally logarithmic functions. And so all of these types of functions, they're really important. And when you get to calculus, if your plan is to take calculus, you're going to be using all of these functions and kind of doing different things with them. And so one of the major goals of this class is to basically add a new type of function to that list. So let me write that down. A major goal of this class is to add another function type to that list of functions that you know how to work with. And so the type of functions I'm talking about here is trigonometric functions. So eventually, if you think about what are all the things that you do when you learn about different types of functions? Well, you evaluate them, you find the domain and range, you graph them, all these different things. I'll list those things out in a moment. And eventually, we're going to do that with trigonometric functions. That's kind of like the bulk of this class is going to be exploring all the different facets, all the different things you can do with trigonometric functions. So eventually, we will work with trigonometric functions. And I'm going to abbreviate. So oftentimes trig is used as an abbreviation for trigonometric or trigonometry. And by the way, I know I still haven't told you what trig functions are, so don't worry, we will definitely get there. But eventually we will work with trig functions the same way you have worked with other types of functions. And so, as I mentioned, that's going to include things like evaluating the functions using function notation. So doing things like f of 5 or whatever, plugging in numbers. We're also going to find the domain and range of different trigonometric functions. You'll also be able to graph different trigonometric functions as well as transformations of those trigonometric functions. You're also going to be learning about the inverses, so inverse functions for trigonometric functions. You're also going to be doing function composition. We're also going to do applications. So these are all different things you can do with functions, right? You can do all these different things with, polynomials, you can do it with linear functions, you can do it with exponential functions, and now we're going to do it with trigonometric functions. But before we can get into doing all that stuff, we need to understand how to evaluate trigonometric functions. But first, we need to learn how to evaluate trigonometric functions. And so I want to kind of give you an analogy. This is probably going to seem like a little bit off topic, but just to kind of make a comparison, there are certain type of functions that are very natural to evaluate. So just to give an example, if you have the function f of x is equal to x squared plus 5, that's an easy to evaluate function, right? You can just say f of 1 is equal to 1 squared plus 5, and you just kind of do arithmetic. So all you need to know in order to evaluate this function is how to square a number and add a number. So it's just kind of using arithmetic. But you've already seen in your classes some types of functions where it did take a little bit more work to learn how to evaluate them. So again, the one on the left is like the kind of simple, intuitive one to evaluate, but you should have also learned about logarithmic functions. So something like log base 2 of x. And so how do you evaluate that? So, g of 1 would be log base 2 of 1. And this is not something that you're going to know how to evaluate unless you learn what logarithms are, right? Like this you could have done, in middle school or even elementary school. This you definitely can't, right? You need to actually know what a logarithm is. And by the way, I'm not going to get into this, but log base 2 of 1 is equal to 0. You can watch if you want I have some 141 videos about logarithms if you're curious about how those work. That's a total side note. Really, the only reason I'm bringing this up is to remind you that there are certain types of functions where it takes some work to actually figure out how to evaluate them. And so that's going to be the case for trigonometric functions. They're going to be functions where you have to learn to evaluate them. So maybe let me just write that down so if you have this in your notes, you understand what's going on. So this is easy to evaluate. And this you had to learn how to evaluate. Okay, one last thing I want to say before we get into trig functions and how they work is I want to kind of give like a little disclaimer for people who've maybe already learned trigonometry. So if you have already learned about trig functions, so whether it was in a previous trigonometry class or a geometry class or sometime in high school, you may be thinking of, oh, trigonometry, that's like opposite over adjacent, things like that. So you may be thinking of, sometimes people use this mnemonic, Sohcahtoa. If you have no idea what I'm talking about, don't worry about it. So this is just addressed to people who kind of already have some preconceived notion about what trigonometry is. So you might be thinking of, oh, right, you draw a right triangle and you have opposite over adjacent, opposite over hypotenuse. That's not what we're going to be doing in this video. So this is not how we will be approaching trig functions for now. So we'll get to that definition later, but for now, I really want you to forget about that definition, and I want you to just listen to the way that I'm going to tell you how we evaluate trig functions, because you really need to understand both ways. And so the first way that we're going to be understanding trig functions, we're not going to be doing Sohcahtoa. So if you don't know what I'm talking about, don't worry about this, but if you do know what I'm talking about, just try to push that to the side of your brain for now and know that we'll come back to that. Okay, so all this buildup, let's actually now talk about what trigonometric functions are. In general, what are the trig functions? Well, there are three main trigonometric functions that we're going to be working with in this class. We'll actually learn that there are three other ones, and we'll get to those in the next video, but these are kind of the three main ones. So the first one is sine. The second one is cosine. And then the third one we're going to be talking about is called tangent. And we're going to be kind of abbreviating them. And so the way that we're going to be abbreviating each of these is that when you're taking sine of an angle, and I'll get to what I mean by that in a moment, you can just write SIN. So SIN is the abbreviation for sine. Sine is the full name, SIN is the abbreviation, and then we'll see why I do this in a second, but when you're evaluating sine, cosine, or tangent, you're evaluating sine, cosine, or tangent of an angle, and so that's why I wrote sine of theta. So theta there represents an angle. So cosine, the way that we abbreviate that is we write COS of theta. So again, cosine is the full name. And the way I would read this out loud is cosine of theta, but we abbreviate it as just COS. And then tangent, as you can probably guess, that's abbreviated as TAN theta. So again, you would read that out loud as tangent of theta, but we can abbreviate it as TAN. So how do these functions work? These functions take an angle, theta, as their input, and they give you a number, and we'll see a little bit more details about what that number is like in a little bit, but they give you a number as their output. Okay, so I know I'm still being pretty vague. How does this actually work? So let's actually define this. So this is probably like the most important moment. I know I've said this a lot at this point, but this trumps all the other previous moments. This right here is like the most important moment of probably the whole quarter. So pay attention. This is really, really, really important. Okay, so if you have an angle, theta, so if theta is an angle, and that angle is in standard position. So I'll sketch an example. So an example of an angle theta in standard position, maybe it could look like, let me make that a little neater. Maybe it could look like this. So maybe this is our angle theta. So if you find the terminal point of that angle. So let me remind myself I want to do some color coordination. Okay, so I'm going to use blue to represent the x coordinate and this magenta color to represent the y coordinate, and we'll see that that is not, that is intentional. Okay, so how do you evaluate sine of this angle and cosine of this angle? Well, sine of the angle is going to be equal to the y coordinate of the terminal point of your angle. So now we can see why we did all this stuff about terminal points, because terminal points are going to be how we evaluate these trig functions. And so as you might be able to guess, cosine of theta, well, that's going to be the x coordinate of the terminal point of your angle. So basically, if you're trying to evaluate trig functions of an angle, you want to take that angle, sketch it in standard position, and then apply all the stuff we talked about in our previous video to figure out what that terminal point is. And once you have the terminal point, the x coordinate will tell you cosine of the angle, and the y coordinate will tell you sine of the angle. So what about tangent? So tangent has like one extra step to it. So to evaluate tangent, what you need to do is take the y coordinate. I'm not going to write out the full sentence, but it's the y coordinate of the terminal point. And you're going to take that y coordinate of the terminal point and divide it by the x coordinate of the terminal point. And so another way of thinking about that is that, well, the y coordinate, that was equal to sine of theta, right? So it's basically like doing sine of theta divided by cosine of theta. That will tell you the value of tangent of theta. Okay, so let's get into an example so you can see how this actually works in practice. So the first thing we need to do is we need to sketch an angle of 7 pi over 6. We need to figure out where that angle lives on the unit circle. So 7 pi over 6, that is 7 times pi over 6, right? And so we can just kind of count out, this would be 1 pi over 6, 2, 3, 4, 5. This would be 6 pi over 6. And that makes sense, right? Because it's pi. 6 pi over 6 is pi. And so 7 pi over 6 would be 30 degrees past 180. So 1, 2, 3, 4, 5, 6, 7. Sorry, it's hard to erase these without erasing the underlying picture. So 7 pi over 6 is going to look like this. So here's our angle of 7 pi over 6. Okay, so how do we evaluate sine, cosine, and tangent? Well, we need to figure out what the terminal point is of this angle. And so this goes back to all the work we did in our last video. So the terminal point means that, we're going to be trying to figure out the x and the y coordinate, which we're going to do by drawing this little right triangle. So I'm going to kind of magnify our right triangle here so that we can see what's going on without it being too cluttered in our picture. So this is the right triangle we're working with. So remember from last time, regardless of what your angle is, you're always drawing the right triangle so that you're drawing a line either straight up or straight down to the x-axis. And so that's where our right triangle comes from. So we can tell just by kind of looking at it that this angle is pi over 3 and this angle is pi over 6 because pi over 6 is the smaller angle. If you want to really be sure, how do I know for sure that these angles are pi over 3 and pi over 6? Well, 6 pi over 6 would be just to here, and we have 7 pi over 6. And so that means we have a little extra to get to our angle. And so let me relabel this. There we go. So we know from our last video, the hypotenuse is going to be 1, and this side is going to be 1/2, and this side is going to be square root of 3 over 2. So using the sides of the right triangle that we just figured out, we can now label this terminal point. So we know that the x and the y coordinate should both be negative because of the quadrant we're in, right? And so the x coordinate is going to be negative square root of 3 over 2. And then the y coordinate is going to be negative 1/2. So I'm just using the side lengths of the triangle that we found, but then applying the correct sign, not sin, but sine, right? Like whether they're positive or negative in order to find the coordinates of that terminal point. Okay, so now we can apply what we learned on the previous page. So on the previous page, we learned that sine of theta is just the y coordinate of the terminal point, and then cosine of theta is the x coordinate of the terminal point. So we know that sine of 7 pi over 6, as we just said, that is the y coordinate of the terminal point, and we know that the y coordinate of the terminal point is negative 1/2. And then cosine, well, we know that that is going to be the x coordinate of our terminal point. So cosine of 7 pi over 6 is equal to negative square root of 3 over 2. So that's sine and cosine. And then how do we find tangent? Well, remember that tangent is going to be our y coordinate over our x coordinate, or personally, I like to just remember it as being sine over cosine. So if you know what sine is and we know what cosine is, you can just divide them. And so in this case, we have sine being negative 1/2. So we put negative 1/2 in the numerator. And then cosine we have as square root of 3 over 2. And so then we can simplify this by, so when you're dividing a fraction by another fraction, that's the same as multiplying by the reciprocal of the denominator. So we can rewrite this as negative 1/2 times negative 2 over square root of 3. And what happens is that these 2's both cancel out. And so we're left with, and also the negative signs cancel out, right? We have a negative times a negative. And so what we're left with is 1 over the square root of 3. And so that's fine. That is the correct answer. Usually we like to rationalize this. So we would multiply this by square root of 3 over square root of 3. And that would give us square root of 3 over 3. And so that is the value for tangent. And then we already found the values for sine and cosine. So basically, what is new in this video is just these definitions of sine and cosine and tangent. You have all the tools to do these because we learned them in our last video. Really, the only kind of tricky part, I'd say, for these is finding the terminal point, and that's something we've already had some practice with. Okay, so let's do another one. So sine, cosine, and tangent of 4 pi over 3. So first thing is sketching 4 pi over 3. So what's that going to look like? Well, it's 4 copies of pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3 would be pi. And so that means that 4 pi over 3 is down here. And again, I'm going to struggle to erase these. I really should just not draw these ones so close. There we go. Okay, so here's our angle of 4 pi over 3. Okay, so how do we go about finding this terminal point? Well, just like in our last example, we want to draw a right triangle. And so again, resist the urge to draw your right triangle going some other way. Always draw your right triangle to the x-axis. And so it's going to look like this. So I'm going to kind of pull this out so we can focus on it. So here's our right triangle. This time, this angle is pi over 3, right? Because we're pi over 3 further than pi. So that means this little angle in here has to be pi over 3. And then that means that this angle has to be pi over 6. And so that means that the horizontal side is our shorter side. So that's 1/2. The vertical side is our longer side. That's square root of 3 over 2. Let me just scooch this down a tiny bit. That didn't catch everything. Okay. Okay, and so that is our triangle. And so now we just need to label the x and y coordinate using those sides and then also the signs of the x and y coordinate. So in this case, the x and y coordinate, they're actually both negative again because we're in quadrant 2 again. And so the x coordinate this time is going to be negative 1/2. So they're both going to be negative, both the x and y coordinate. And now the y coordinate is going to be negative square root of 3 over 2. So this is actually kind of similar to our last example. It's just that the x and y coordinates are flipped. And that kind of makes sense because we're dealing with the same types of angles. We just kind of switched the orientation of the triangle. Okay, so we know that sine of theta, or in this case, sine of 4 pi over 3, is supposed to be the y coordinate. So that's negative square root of 3 over 2. We know that cosine of 4 pi over 3 is supposed to be the x coordinate of the terminal point, and so that's negative 1/2. And then we know that in order to find tangent, we want to divide those. We want to do sine over cosine. So sine is going to be negative square root of 3 over 2, and then cosine is negative 1/2. So like we did in our last example, we can rewrite this as negative square root of 3 over 2 times negative 2 over 1. So multiplying by the reciprocal of the denominator. And once again, these 2's cancel out. So, you might actually, once you do these a few times, you might get used to this fact that if you have the same denominator here and here, you can just kind of cancel them out actually without doing this kind of rewriting. But just to avoid making mistakes, I would recommend using this rewriting method if you're at all not sure about how this cancellation works. So we also get our negative signs to cancel out, and we're left with tangent is equal to just square root of 3 over 1, which is just square root of 3. So notice that's the reciprocal of what we got the last time. So the last time we got 1 over square root of 3, which we then simplified to square root of 3 over 3. But it's the reciprocal because sine and cosine just flipped in this example compared to the last one. In the last time, sine was negative 1/2, cosine was square root of 3 over 2. They flipped, and so that means that tangent also flipped. Okay, I wish I didn't put these examples so close together, but let's do another one. So this next one is going to be sine, cosine, and tangent of now negative 5 pi over 6. So now we're working with a negative angle, so it's not between 0 and 2 pi, but again, the method is still the same. We want to figure out where is this angle and then figure out what its terminal point is. So negative 5 pi over 6, that means that we're doing 5 copies of pi over 6, but we're going in the negative direction. So we have negative 1, 2, 3, 4, 5. So negative 5 pi over 6 is going to be here. So this is negative 5 pi over 6. Okay, so what are the coordinates of this terminal point? Well, notice that we actually already figured that out. So if I scroll back up to our first example, when we did 7 pi over 6, we found the coordinates of that terminal point. And notice that negative 5 pi over 6, it's not the same angle, but it is coterminal with 7 pi over 6. So let me write this down. So this angle, negative 5 pi over 6, is coterminal with 7 pi over 6. And when angles are coterminal, they have the same terminal point. And so we don't need to do the work for this again. I'm just going to recopy what we had here. So we found that our x coordinate was negative square root of 3 over 2, and our y coordinate was negative 1/2. So I'm just going to rewrite that down without justifying it, because it's just the same as what we got earlier. And so what is that going to mean about sine, cosine, and tangent? Well, they're going to be the same that we got above, right? It's just going to be the same exact thing. So sine of negative 5 pi over 6 is going to be our y coordinate. So that's negative 1/2. Cosine of negative 5 pi over 6, that is going to be the x coordinate, which is negative square root of 3 over 2. And then tangent of negative 5 pi over 6, well, that is going to be what we found above, right? Because we already did this. We already found that, that if you take sine over cosine, where sine is negative 1/2 and cosine is negative square root of 3 over 2, we went through all the work and we found out that it was square root of 3 over 3. So I'm just going to rewrite that answer down here. So this is a really important example because this is something we've been kind of building up to with talking about coterminal angles. And really the reason we keep talking about coterminal angles is because of this fact. So what did we see happen in this case? We saw that when you have coterminal angles, their terminal point is the same. If their terminal point is the same, that means that you're going to get the same thing when you do sine, cosine, and tangent, right? Because the way that you find sine, cosine, and tangent is by looking at the terminal point. So I want to write this down in general. This is, like I said, this is important. So I'll write down, I'll bold this and say, important fact. So our important fact is the fact that if I'm going to call angles theta 1 and theta 2. So I'm just using that to represent like two different angles. So if you have two different angles, theta 1 and theta 2 are coterminal angles, then if you evaluate sine, cosine, and theta of them, you're going to get the same result both ways. So sine of theta 1 is going to be equal to sine of theta 2. That's what we saw happen in this example, right? And then cosine of theta 1 is equal to cosine of theta 2. And then if sine and cosine are both equal, then tangent's also going to be equal because you find that using sine and cosine. So I know there's a lot of kind of symbols in this definition, but really the main thing to understand here is just that if you have angles that are coterminal, when you evaluate trig functions of those angles, you're going to get the same result because they're coterminal angles. So there's one more thing that I want to talk about. So in order to kind of get to this idea, we're going to talk about a different way to think about tangent. That in some cases can kind of make it easier to evaluate tangent so that you don't have to do all this division. So in order to kind of build up to that, I want to do a couple more examples that will bring up some things that we haven't seen happen yet. Okay, so this time we want to find sine, cosine, and tangent for a few more angles. So we're going to start with pi over 2. So how do we find sine, cosine, and tangent of pi over 2? Well, we just need to graph our angle, locate our angle of pi over 2, and find the terminal point, and then we can use that to find sine, cosine, and tangent. So in this case, the terminal point does not involve drawing any triangles, right? We can just eyeball this and say, okay, the terminal point is going to have an x coordinate of 0 and a y coordinate of 1, right? Just by looking at where this point is located. And so that tells us that, sorry, let me go back to my color coordination here. That tells us that sine of pi over 2 is equal to 1, right? Because that's our y coordinate. It also tells us that cosine of pi over 2 is equal to 0, because that's the x coordinate of our terminal point. And then finally, if we want to do tangent of pi over 2, as we saw in our earlier examples, we do the y coordinate divided by the x coordinate. So in this case, that is 1 divided by 0. So you can't divide by 0, right? That is undefined. And so basically what this tells us is that tangent of pi over 2 is undefined. And so we'll see that that is never going to happen with sine and cosine, but it does happen with tangent. So, sine and cosine are not really involving division, right? You're just looking at the x and y coordinates of your terminal point. Whereas tangent, that is going to involve division. And so if cosine happens to be 0, then you're always going to get an undefined result for tangent. So just be aware that tangent is sometimes undefined. Okay, so similar here. And by the way, if you haven't already, I would recommend pausing the video and trying this yourself. So let's do now theta is equal to pi. So pi is 180. And so again, this is one where we don't need to actually calculate our terminal point. We can just kind of look at it and figure out what it is. So the x coordinate in this case is -1, and the y coordinate is 0. And so that tells us that sine of pi is going to be equal to 0, right? Because that is the y coordinate of our terminal point. And then cosine of pi is going to be equal to -1, because that is the x coordinate of our terminal point. And then tangent of pi, well, again, we do our y coordinate divided by our x coordinate, or sine over cosine. So that's 0 divided by -1. So what is that equal to this time? Well, 0 divided by a number, that's not undefined unless it's 0 over 0. So 0 divided by -1, there's nothing wrong with that. That's just equal to 0. So important fact to remember, dividing by 0 gives you an undefined result, but 0 divided by a number, that is okay. And so tangent of pi, it's not undefined, it's just 0. So tangent can be undefined, tangent can be 0. It really depends on whether it's sine or cosine that is equal to 0. So if cosine is equal to 0, like we saw here, that's where we get something that's undefined. If sine is equal to 0, then tangent is also equal to 0. All right, one more example. So this one is 11 pi over 4. So this is going to be one where it's not between 0 and 2 pi, so we have to do a little extra work to figure out what this angle looks like. So 11 pi over 4, well, that's the same thing as 11 over 4 pi. And 11 over 4 is bigger than 2. So we know that this angle is bigger than 2 pi. And so we want to figure out, this is going to be equal to 2 pi plus something. So how much bigger than 2 pi is this? Well, we can rewrite 2 pi as 8 pi over 4. And then we can see from there that, okay, we're missing 3 pi over 4 in order to get to 11 pi over 4. And so our angle is going to be 2 pi plus 3 pi over 4. So what is this angle going to look like? Well, it's going to involve going all the way around. So this would be our 2 pi portion. And then it's going to keep going to 3 pi over 4. So what does 3 pi over 4 look like? Well, here's 1 pi over 4. 2 pi over 4 would be pi over 2. So 3 pi over 4 is over here. And so our angle is going to be, let me just draw that a little better. Our angle is going to be like this. It's going to be like going all the way around and then stopping at 3 pi over 4. So here is what 11 pi over 4 looks like. And so this angle is coterminal with 3 pi over 4. So it's going to have the same terminal point just as if it was 3 pi over 4. So how do we find our terminal point? Well, again, we want to draw a triangle. And so this time, we haven't done an example like this yet in this video, but we did plenty of them in our last video. This time it's going to be a 45, 45, 90 triangle. So this angle is pi over 4, and this angle is pi over 4. And we can tell that because basically, we're looking at the angle 11 pi over 4 here, but because it's coterminal with 3 pi over 4, you can just kind of think of it as being like 3 pi over 4 in the context of actually figuring out this triangle. So this angle here is 3 pi over 4, right? And so in order to get to pi, the remaining angle here must be pi over 4. Okay, let me just relabel this, and actually this is messy and it's bothering me. So I'm just going to rewrite this. Okay, so if we have pi over 4 and pi over 4, our hypotenuse is 1. And so these sides are square root of 2 over square root of 2. We're in quadrant 2. And so that tells us that our x coordinate is going to be negative and our y coordinate is going to be positive. So we're going to have, for our x coordinate, negative square root of 2 over 2. And for our y coordinate, we're going to have positive square root of 2 over 2. Okay, so now we're ready to evaluate sine, cosine, and tangent. So sine of 11 pi over 4 is our y coordinate. And so our y coordinate is square root of 2 over 2, positive. Cosine of 11 pi over 4 is negative square root of 2 over 2. And then I'll write tangent here because I think I might run out of space if I do it below. So tangent of 11 pi over 4, that just means we take sine divided by cosine, right? And so we're going to have square root of 2 over 2 divided by negative square root of 2 over 2. And so you totally could rewrite this the way we've been doing, multiplying by the reciprocal and then cancel stuff out, but you don't have to do that here because notice that the numerator and the denominator are exactly the same except for that the denominator has a negative sign. So what happens if you divide two of the same numbers but one of them has a negative sign? Well, that simplifies to being negative 1, right? It's kind of like if you had, 5 divided by negative 5, that would be negative 1. Same idea here, same number divided by itself, but negative. Okay, so that is now going to bring us to the next thing I just want to quickly mention, which is another way to think about tangent. So again, just to remind you what happened in these examples, the first one we found that tangent was undefined. The second one we found that tangent was 0. The third one we found that tangent was negative 1. So if you look at those numbers that we got and then you look at the picture, one thing that you might notice is that the slope of the terminal side that we drew actually matches up with what we found for tangent. So for example, in this picture, what would be the slope of this side that I just highlighted in green? Well, it would be negative 1. So how can I tell that? Well, when a line has a slope of positive or negative 1, it's kind of going perfectly straight halfway through a quadrant, right? And so in this case, it would be negative 1. So if I were to kind of extend this line like this, that's a line with a slope of negative 1. And negative 1 is exactly what we found for the value of tangent. So looking now at this example, this one, we had a terminal side that was just kind of flat and horizontal. So if you were to extend this into just a flat horizontal line, what is the slope of a horizontal line? It's 0, and that's exactly what we found for tangent. And then this example here, well, this is a vertical line. So if you think back to when you first learned about lines and linear functions, you should have learned that a vertical line has an undefined slope. If you try to calculate the slope, you'll divide by 0 and you'll find that it's undefined. So this is not a coincidence. This is always true. So I want to kind of write that down and then kind of show you why that's the case. So another way to think about tangent of theta is that tangent of theta, and by the way, you might notice here I didn't put parentheses. You can write it either way. I kind of like to put parentheses around theta to emphasize that it's your input, that you're evaluating a function, but you can also do it without the parentheses if you want. So tangent of theta is equal to the slope of the terminal side of theta. So why is that the case? We saw a few examples that kind of demonstrated why that was the case, but I really want to kind of convince you that it always works. So I'm just going to draw some random angle theta here. So let's say that this is our terminal side. Sorry, I'm struggling to draw this nicely. There we go. So let's say this is our terminal side, and we have some angle theta here. And so let's say that this angle theta has an x-coordinate and a y-coordinate that I'll just label generically. So I'm just going to label this as x and as y. So we know that tangent can be found by doing y over x, right? Sine over cosine. So we'll come back to that in a second, but let's maybe first think about how would you calculate the slope of this green line segment? So maybe let me just write down here, like, why is this the case? So why is this true? Okay, so let's say you wanted to find the slope of the terminal side. So the slope of that line segment that I drew in green. So how do you find the slope of a line or a line segment in general? Well, you do the change in y over the change in x, right? You need 2 points, and you need to figure out what's the change in y over the change in x. And so here we have 1 point, right? 1 point is xy. The other point that we could use is just 0, 0. So how would you find the slope of the terminal side? We would do the change in y. I'm going to use, you may have seen this symbol before. Delta, this symbol means change in. That's what that delta symbol means, that triangle. So we're going to do our change in our y coordinates over our change in our x coordinates. So in this case, what would that end up being? Well, the change in the y coordinates would be y minus 0. And then what would the change in the x coordinates be? Well, that would be x minus 0. Right? So all I'm doing here is just writing down, you might have learned this as like y2 minus y1 over x2 minus x1. I'm just doing that using these 2 points, xy, because that's what we decided to label our terminal point, and then 0, 0, because the terminal point the terminal side starts at the origin. And so what does this simplify to? If you take this y minus 0 over x minus 0, well, that just simplifies to y over x. And so what is our definition that we learned earlier for tangent of theta? Well, we also learned that tangent of theta is equal to y over x, right? The y coordinate of the terminal point over the x coordinate of the terminal point. And so what we just saw is that we got the same result both ways. So regardless of whether you think of this as slope or whether you use our definition of tangent, it's the same. So this is not like the most useful way to calculate tangent because, really you might not be able to just eyeball the slope and see what it is. You probably will still need to calculate it. Where this is helpful is basically in examples like these 3 that we just did. So if you have a multiple of pi over 2, your terminal side is either going to be vertical or horizontal. So if it's vertical, you can quickly eyeball it and say, oh, well, a vertical line has undefined slope, and so tangent must be undefined. And then if your terminal side is horizontal, well, we know that a horizontal line has a slope of 0, and so tangent must be 0. And then the other place it's helpful is when you have multiples of pi over 4, you're either going to end up with a slope of 1 or -1, depending on what that multiple is. So it's not going to be so useful in examples like the one that we did here, things like square root of 3 over 3. You can't really eyeball that, but it is nice for just quickly computing tangent in certain cases. So let me just write that down, and that will be kind of the last thing in this video. So this is useful for finding tangent of theta when theta is a multiple of pi over 4. I'll say pi over 4 or pi over 2. Technically, pi over 2 is a multiple of pi over 4, so I don't need to write both. But my point is basically when you have these angles that are either kind of halfway between one of your quadrants, so that would be a multiple of pi over 4. And that will be the cases where the slope is -1 or 1. So slope of either 1 or -1. And then if your angle is a multiple of pi over 2, well, it's either going to be vertical or horizontal. And so that's going to be a slope of 0 or undefined. So just kind of a little shortcut that I just wanted to mention, but the main way that you're going to be calculating tangent is by doing y over x. All right, so that is it for this video. Please take a look at the worksheet. I think the most important thing you can do here is just practice evaluating sine, cosine, tangent. In our next video, we'll do some more examples. We're going to introduce 3 more trig functions, but don't worry, if you know these 3, they're basically just kind of a variation of these 3. And then we'll talk a little bit about some other kind of context, some other ways of approaching evaluating trig functions. So I'll see you all in our next video.